morning, everyone. Today we are going to deal a beautiful and important topic of mathematics, that is the differential equations. So an equation involving derivatives is called a differential equation. So there are two types. One is ordinary differential equation. A differential equation involving ordinary derivatives. Ordinary derivatives means we are differentiating with respect to a single independent variable is called an ordinary differential equation. So these are the examples: dy by dx plus y by x is equal to x square, and another example is d square y by dx square plus 5 dy by dx plus 6y is equal to 0. So ordinary differential equation means an equation involving ordinary derivatives. So next we are going to define partial differential equation. A differential equation involving partial derivatives. That means the derivatives with respect to two or more independent variables is called partial differential equation. So this is the example: x dou u by dou x plus y dou u by dou y is equal to 2u. You can write so many examples here. Next, today we are going to deal ordinary differential equations. So before entering into ordinary differential equation chapter, so first we have to discuss about the three important concepts in the chapter. One is order and degree, and the second one is formation, and third one is solving the differential equation. So first of all, we are going to define order of a differential equation. The order of a differential equation is the order of the highest order derivative appearing in it. For example, if you take y is equal to f of x, so its first derivative will be dy by dx. It is called first order derivative. Again, if you differentiate with respect to x, so you will get d square y by dx square. That is second order derivative. Again, if you differentiate, you will get d cube y by dx cube. This is third order. Similarly, if you differentiate with respect to x n times, so finally you will get dn y by dx n. That is called nth order derivative. So this is first order, this is second order, this is third order. So if you differentiate with respect to x n times, you will get nth order derivative. So this is called order. So if any equation contains first three derivatives, that means dy by dx, d square y by dx square, d cube y by dx cube. So if any equation contains these three derivatives, so in these three derivatives, what is the highest order? That is third. Highest order derivative is d cube y by dx. Therefore, the order, by the definition, the order of the differential equation is 3. So you see this example: d square y by dx square plus 5 into dy by dx whole power 4. This is d cube y by dx cube. This is second order. This is first order. Of course, we are raising it 4 times, but it is a first order. And this is d cube y by dx cube. So in this complete equation, what is the highest order derivative? This is highest order derivative. Therefore, its order is 3. And next, you take one more example: d square y by dx square plus 5y is equal to dy by dx whole cube. This is second order, and this is first order. So in which second order is the highest. So therefore, obviously, the order of the differential equation is 2. So order of the differential equation is the order of the highest order derivative in the given differential equation. So I think it will be clear. Next, we are going to define degree. The degree of the differential equation is the power of the highest order derivative appearing in it. Is the power of the highest order derivative appearing in it after the differential equation has been made free from radicals and fractions as far as the derivative concerned, or simply before we are going to find the degree of the differential equation, first it should be free from radicals and fractions, the given differential equation. That means it should be expressed as a polynomial in derivatives. Whenever you convert the given differential equation is a polynomial in derivatives, then you can write the degree of the differential equation. So after it is a polynomial, then you have to observe the highest order derivative. Its power is called degree. Very simple thing. The highest order derivative order is the order. The highest order derivative power is the degree. But whereas if you find the degree, just you convert the given equation into polynomial and derivative. So that is the important thing. So now you will see some more examples here. You can write its orders and degrees also. So in the first equation, this is d square y by dx square plus 2 into dy by dx whole square plus 2y is equal to sin x. This is second order. This is first order. So in this equation, the highest order derivative is this one. That means its order is 2. Therefore, the order of the differential equation is 2. Next, you observe the highest order derivative. Its power, you see, its power is 1. Therefore, its degree is 1. So, order of the differential equation is the order of the, this is order, you see, this is order, and its power is degree. The highest order derivative, order is the order and its power is the degree. And next you see the second example. Root of 1 plus dy by dx is equal to d square y by dx square. But it is not a polynomial equation. So first directly you can say that its order. No doubt its order is 2, since second order derivative is there. That is the highest order. Therefore order is 2. So before going to find the degree, first you express the given equation into a polynomial. For that you can squaring on both sides. Then you will get 1 plus dy by dx is equal to d square y by dx whole square. Therefore what is the highest order here? D square y by dx square. Its power is 2. Therefore degree is 2. So this is the second example. Next you take the third one. 1 plus d cube y by dx cube power half is equal to d square y by dx square. So what is the highest order? Third. This is the third order derivative is the highest order. Therefore obviously order is 3. And to find the degree, definitely you should express the given equation into a polynomial. For that squaring on half is there, power half is there. So it should be free from fractions. For that you squaring on both sides. If you square on both sides, this half will be cancelled. And this side you will get power 2. Therefore 1 plus d cube y by dx cube is equal to d square y by dx square whole square. Therefore highest order is d cube y by dx cube, that is the left side. Its power will be 1. Therefore degree is 1. Okay, clear? Next you see the fourth example. 5 plus dy by dx whole square power 5 by 3 is 7 into d square. The highest order derivative is second order. Therefore order of the given differential equation is 2. No doubt. And 5 by 3 is there. There is a fractional part. To remove that fractional part, cubing on both sides. So this 5 by 3, 1 by 3 will be cancelled and it will be power 3. So in the right side there is a highest order derivative, that is d square y by dx square. Its power is 3. Therefore degree is 3. And next you see the fifth example. 5 plus dy by dx is equal to 4 by dy by dx. So after cross multiplication we will get, so this actually dy by dx in the denominator. So if it comes to the numerator, power will be minus 1. As for our definition of degree, as for the definition of the degree, it should be free from fractions and radicals. So if dy by dx power is minus 1, then it is not a polynomial in derivative. So that is why. So you take the cross multiplication. So after the cross multiplication, you will get 5 plus dy by dx into dy by dx is equal to 4. Order is no doubt it is 1. And dy by dx into dy by dx, after multiplication you will get dy by dx whole square. Therefore its degree will be 2. And next you see the last one, log of dy by dx plus 5y is equal to x. No doubt only first order is there, therefore order is 1. It's very clear. And while finding the degree, it's cannot be expressed as a polynomial, so therefore in this case degree is not defined. So this is the process to find order and degree of a differential equation. I think so it will be clear. That is the first concept of the differential equation. What is the first concept of the differential equation? Order and degree. So let us go for the second one, that is formation of differential equation. So when any general equation is given, you have to differentiate that general equation, then you have to form a differential equation. Suppose if any general equation contains two arbitrary constant, you have to differentiate with respect to x 2 times and eliminate those arbitrary constants from that equation, then that is called a differential equation. That is the process to form a differential equation. You see, f of x comma y comma c1 c2 cn is equal to 0. This is a general equation. So in this equation we have n arbitrary constants, that is c1 c2 so on cn. Therefore we have to differentiate with respect to x n times, and finally we should eliminate all these arbitrary constants. By eliminating all these arbitrary constants from n plus 1 equations, this is the first equation. If you differentiate with respect to x n times, then we will get n more equations. Totally we will get n plus 1 equations. By using these n plus 1 equations, we have to eliminate c1 c2 so on cn, then you will form a differential equation. So this is the process to form a differential equation. You see here, you see the examples. So the first example is let y is equal to mx, where m is an arbitrary constant. We have only one arbitrary constant, so that is why you have to differentiate with respect to x only one time, that is y1 is equal to m. And by using these two equations we have to eliminate m. For that you have to substitute m in the first equation, then you will get y is equal to x y1. This is the differential equation. So it's very, very simple. So you have to differentiate with respect to x, that if one time or two times, it is depending on number of arbitrary constants. You see the second example, we have two arbitrary constants a comma b, so therefore definitely we have to do differentiate with respect to x two times. y1 is equal to a e4x minus b e4 minus x, and second derivative you know that a e4x plus b e4 minus x, but this a e4x minus b e4 minus x is nothing but y, therefore y2 is equal to y, and y2 minus y is equal to 0. So in the final equation there is no a and no b. So the process is you have to differentiate with respect to x of given general equation. It's depending on number of arbitrary constant. If two arbitrary constant, you have to differentiate two times. Finally you eliminate those arbitrary constant, then a differential equation will be formed. That is the process. And you take one more example here. Y is equal to a cos 3x plus b sin 3x, where a comma b are arbitrary constant. Similarly you have to differentiate. This is the first derivative, you know that cos 3 cos x derivative is minus sin x, and the sin derivative will be cos 3x, 3x derivative will be 3, and y2, and if you take minus 9 common, a cos 3x plus b sin 3x, that is y, y2 plus 9y is equal to 0. So this is the process. Whenever if it is a cos nx plus b sin nx form is there, instead of 3, if any number is there, the answer will be y2 plus m square y is equal to 0, or if it is m, y2 plus n square y is equal to 0. If it is m, y2 plus m square y is equal to 0. So simply you can write in this form. The answer is y2 plus m square. M is this number. If m is equal to 3, 9y, m is equal to 4, 16y. And you take one more example, y is equal to a cos nx plus b. So in the same way you can differentiate with respect to 2 times, where a comma b are arbitrary constant. For this question also the same shortcut, y2 plus m square y. Not only y is equal to a cos nx plus b, if y is equal to a sin mx plus b also, you will get the same answer. Okay, next you see the fourth example. Y is equal to a e4 2x plus b e4 3x, where a comma b are arbitrary constant. So y1 and this is y1. By using y, you can write y1 can be expressed 2y plus b for 3x. Again, you have to differentiate. You will get 2y1 plus 3b for 3x. Finally, you will get this answer. That means what process we are adapting here means we are differentiating y with respect to x 2 times and eliminating the arbitrary constant. That is the main important thing to form a differential equation. Instead of for some questions it is very difficult to adjust the problem. For that, when these are the three equations, y1, y2, y3, y1, y2. So from three equations we have to eliminate two arbitrary constant. Then the process is the coefficient matrix of those arbitrary constant is 0. So this is the coefficient matrix of the given arbitrary constant. After simplification, you will get the same answer. And this is one process. Adjusting the values of first, second, and third equation, you can eliminate a and b. That is the first thing. And coefficient matrix of arbitrary constant is 0. So in that process also you will get the answer. And third there is a shortcut. A for alpha x plus b for beta x. This is alpha and this is beta. Then directly you can use this formula. y2 minus alpha plus beta y1 plus alpha beta y. That is 2 plus 3 is 5y1 plus alpha into beta. 2 into 3, 6y is equal to 0. So this is the process to eliminate arbitrary constants. Similarly, so if ABC are three arbitrary constant, you can use this formula. This is also a shortcut. Alpha 1, alpha 2, alpha 3 into y is equal to 0. A e4x plus b e4 2x c e4 3x. y3 into this is 1 plus 2 plus 3. 1 into 2 plus 2 into 3 plus 3 into 1. y1 and minus, just alternate sign. y3 minus plus minus 1 into 2 into 3. So that is the answer. Next, y is equal to ax square plus bx. Again, we have the same process. A and b are arbitrary constant. y1 is equal to 2ax plus b, y2 is equal to a. So from b, you can write y1 minus ax xy2. And from the first equation, you have to substitute ab values. So from the third equation, you will get a value. From the second equation, you will get b value. Put ab values in the first equation. So you will get a differential equation. Instead of doing all these things, there is one more shortcut to this problem. That is x square y2 minus, if it is x power is n and b into this power is n, the answer will be m plus n minus 1 xy1 plus mny is equal to 0. You can use the same shortcut here. X square y2 minus m plus n. This is 2. This is 1. 2 plus 1. That is 3 minus 1. Therefore, this is 2x. Right. Next, m and y. 2 into 1. That is 2y is equal to 0. So this is the process to find the to form the differential equations. And these are the two shortcuts for a different problems. Y is equal to e4 alpha x into a cos beta x plus b sin beta x, a and b. So you can use this formula. And example, y2 minus 2 alpha. Alpha is 2 and beta is 3. You can substitute, you will get the answer. And y is equal to e4 alpha x into ax square plus bx plus c, where a, b, c are arbitrary constant. You can use this formula. So this is the process to form a differential equation. To forming a differential equation is very easy. First, you observe the number of arbitrary constants in the given differential equation. In the given general equation, you have to differentiate the given general equation. Suppose 2 or 3 arbitrary. Suppose 3 arbitrary constants are there. So in this example, we have 3 arbitrary constants. So you have to differentiate with respect to x 3 times and eliminate those arbitrary constants. Then a differential equation will be formed. So this is the process. And what is the first concept here in differential equation? The first concept is order and degree. I think that will be clear. And the second concept is formation of differential equation. So now we are going to deal with the last concept, an important concept, that is solving the differential equation. So we are solving the differential equation here, particularly first order and first degree. So first we are going to solve the differential equation of first order and first degree. So to solve the first order and first degree differential equation, there are some methods. We have 6 methods are there. One is variable separable method, and the second one is homogeneous equation, and the third one is non-homogeneous equation, fourth linear equation, fifth Bernoulli's equation, and the last exact differential equation. So first we are going to deal variable separable method. Let dy by dx is equal to f of x comma y be a differential equation. If one can be expressed as dy by dx equal to f of x by g of y, dy by dx is equal to g of y by f of x. In these two forms, we have to use this method. So after that, whenever the question is in these two forms, so you take the cross multiplication. This is g of y dy f of x dx. So then if you get in this form, g of y dy is equal to f of x dx, or d of y by g of y is equal to d of x by f of x, in this form, dx by f of x, in this form. If finally if you get in this form, then this method is applicable. After this integrating on both sides, whenever the problem is in this form, that means x term into some dx, y terms into dy, or dx by some variable, dy by variable. If you get in that form, then we have to use variable separable method. So whenever the question is in that form, then you take the integration on both sides. So this is integral f of x dx is equal to integral g of y dy, and write the constant of integration, that is dx by f of x dy by g of y plus c. You see one example, dy by dx is equal to x by y. So what is our process? You write y terms at dy and x terms at dx. By cross multiplication, you will get y dy is equal to x dx. Whenever you get in this form, you have to take integration. Use integration. Integral y dy, integral x dx. Integral y will be y square by 2, and integral x will be x square by 2 plus c. So this is x square minus y square is equal to 2c. But in the chapter, this is c is the constant of integration. Sometimes it may be c by 2 or c. If you write just a capital C or k. So that is the constant of integration. In constant of integration, for numerical values, there is we don't have any importance for constant of integration. So it may be c or 2c or 3c or c by 2, whatever it means, sometimes log c. So just ignore the constant of integration coefficients. Next, you see dy by dx is equal to y by x. This is dy by y is equal to dx by x. So again, you have to take the integration on both sides. Integral 1 by y is log y, 1 by x is log x, plus constant of integration, since it is in the log form, that is why instead of c I am taking log c. So log y is equal to log a plus log b, this is log cx. Log y is equal to log cx, you will get y is equal to cx. That is a solution of general solution of given differential equation. And so this is dy by root 1 minus x square dx. So whenever the question is in this form, you have to take the integration. Its derivative is sin inverse y, derivative sin inverse x, that is equal to c. And dy by dx is equal to 2xy by 1 plus x square. Write y term at dy, that is dy by y, and by cross multiplication, this is 2x dx by 1 plus x square. So after getting into this form, then you have to take the integration. 1 by y integral will be log y, and this is f dash x by f of x form. Its derivative is log 1 plus x square. What is the derivative? What is the integral of f dash x by f of x? Log f of x. So 1 by y integral will be log y, 1 by 1 plus x, 2x by 1 plus x square into the log 1 plus x square plus log c. y is equal to this log a plus log b. You can write log c into 1 plus x square. Therefore, y is equal to c into 1 plus x square. And dy by dx is equal to x plus y whole square. This is an implicit function, so we cannot split the x and y terms separately. So in this case, you have to take x plus y is equal to u. So after substitution, you have to differentiate 1 plus dy by dx is equal to du by dx. Therefore, dy by dx is equal to du by dx minus 1. Let's put dy by dx is equal to du by dx minus 1 is equal to, you will get u square. Du by dx is equal to, you will get u square plus 1. So then you write du by u square plus 1 is equal to x. This is 1 by 1 plus u square. 1 by 1 plus x square integration, we will know that tan inverse x. This is tan inverse u, and integral 1 will be x. And finally, you write u is equal to x plus y. Therefore, it is tan inverse of x plus y is equal to x plus c. So that is the first method. And we will go for the second one, homogeneous differential equation. So we know that homogeneous function. What is homogeneous function? So if f of kx comma ky is equal to k to the power of n f of xy, then f of x comma y is said to be homogeneous function of degree n. So here we are going to define homogeneous differential equation. Differential equation, let dy by dx is equal to f of xy is called homogeneous differential equation in x and y. If the function f of x comma y is a homogeneous function of degree 0. So that means you have to find the degrees of a homogeneous function. If degree is 0, then that homogeneous, then that equation is a differential equation is said to be homogeneous differential equation. So here you check the homogeneous function f of x comma y. To find the degree of homogeneous function, the process is you write x is equal to kx and y is equal to ky. This is k square x square into ky. That will be k cube into x square y. This is x cube, k cube x cube, k cube y cube, k cube common, x cube plus y cube. So this get cancelled, you will get k power 0. Therefore, it is homogeneous function of degree 0. Or simply, if x power n is common, if you take x cube is common, this is x cube into y by x and x cube into 1 plus y cube by x cube. That means if you take x power n is common, it can be expressed as f of y by x. That n is called a degree. So whenever it is homogeneous function of degree 0, then the process or the method or working rule to solve a homogeneous differential equation is you take y is equal to vx. After substitution, the regular process will be dy by dx equal to v plus x dv by dx. So you take suppose instead of dy by dx is equal to f of xy, it is dx by dy is equal to f of x by y. In this case, you have to take x is equal to vy, dx by dy is equal to v plus y dv by dy. Here we have to take two examples here. One is in the form of dy by dx form and another one is dx by dy form. So this is dy by dx is equal to, you will get x square plus y square by 2xy. So it's 2, it's 2 and 1 plus 1, 2. So clearly it is homogeneous function. It is very, very clear that it is homogeneous function of degree 0. Therefore, it is homogeneous differential equation. Whenever it is homogeneous differential equation, then you take y is equal to vx. After that, substitution is dy by dx is equal to v plus x dv by dx. This is v plus x dv by dx. This is x square. This is v square x square. 2x square v. X square get cancelled. You will get 1 plus v square by 2. X dv by dx is equal to 1 plus v square by 2v minus v. So after simplification, you will get this one. Again, it is variable separable method. The problems comes to under variable separable method. Therefore, you write v terms at dv and x terms at dx. Then you have to take in the integration. So this is 1 minus v square derivative is minus 2v. Therefore, you multiplied by minus sign. This is dx by x plus log c. Clearly, it is f dash x by f of x. Therefore, minus f dash x by f of x is log of f of x. 1 by x integral will be log x plus log c. This is 1 minus v square power minus 1 cx. And we are taking y is equal to vx here. Therefore, v is equal to, finally we are writing y by x. So after simplification, we will get this one. And power minus 1 is there. Therefore, this is x square by x square minus 1 equal to cx. So after cancelling x, you will get the solution. So this is dy by dx. If the given homogeneous differential equation is in the form of dy by dx is equal to f of x comma y by g of x comma y form. So instead of that, it is dx by dy form. So this is y dx is equal to x plus root y square minus x square dy, dx by dy. So in this case, you have to take x is equal to, if it is dy by dx is equal to f of x comma y by g of x comma y, you have to take y is equal to dx. dx by dy is equal to, it's a homogeneous function in the form of f of x comma y by g of x comma y. Then you take x is equal to by. After substitution, we know that differentiation dx by dy is equal to b plus y dv by dy. So after simplification, so this y will be cancelled and vv will be cancelled. Again, it is variable separable method. dv by root 1 minus y square is equal to dy by y. So after that, you have to take the integration. 1 by root 1 minus y square is sin inverse v. 1 by y is log y plus log c. Sin inverse x y is equal to log c by. So this is the third one. So first one is a variable separable method, and the second one is homogeneous equation, and the third method is non-homogeneous equation. So dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. C1 comma C2 not equal to the other conditions, of course. So the working rule is, again we have three cases to solve this non-homogeneous equation. First case 1, if b1 is equal to minus a2, that means the coefficient of y in the numerator is equal to minus of coefficient of x in the denominator, that is b1 is equal to minus a2, then the process is cross multiplication and use term by term integration. You take one example on this one. dy by dx is equal to x plus y plus 1 by minus x plus y plus 1. You see, y coefficient is 1 in the numerator, that is b1 is equal to 1 and a2 is equal to minus 1. Therefore, clearly b1 is equal to minus a2. So then you have to take the cross multiplication. So after cross multiplication, you will get this one. So then you write y dy plus dy is equal to x dx plus dx. This minus x dy comes to the right side. This x dy plus y dx. So in the next step, you can write that is d of x y uv form. Next, by term integration, integral y dy, integral dy, integral x dx, integral dx, integral dxy. Integral y dy is y square by 2, this is y, this is x square by 2, this is x. So d of xy integral will be xy plus c. After simplification, you will get this answer. This is the first method. And the second method is if a1 by a2 is equal to b1 by b2. For non-homogeneous, this is the second case. dy by dx is equal to x plus y plus 1 by 2x plus 2y plus 1. You see the coefficients. This is a1, this is a2, a1 by a2, 1 by 2, b1 by b2, 1 by 2. So it is very clear that a1 by a2 is equal to b1 by b2. So dy by dx is equal to x plus y plus 1. You can take 2 common, x plus y plus 1. Let us suppose x plus y is equal to u. So after substitution, obviously you have to differentiate. 1 plus dy by dx is equal to du by dx. dy by dx minus 1 is equal to u plus 1 by 2u plus 1. After simplification, you will get this method. So again, it is variable separable method. So you can solve this differential equation by using variable separable method. Next, if last case, if the first case is failed, that means b1 is not equal to minus a2 and a1 by a2 is not equal to b1 by 2, then the process is you have to take x is equal to x plus h, y is equal to y plus k. You substitute x is equal to x plus h, y is equal to y plus k. The given differential equation, automatically after substitution, it is converted into homogeneous. Whenever it is converted into homogeneous, then you take y is equal to vx. So after that, the substitution of y is equal to vx, the problem comes to variable separable method. First, it is non-homogeneous. Whenever you give these two substitutions, it will be converted into homogeneous. So after you have to give the substitution y is equal to vx, then automatically it will be converted into variable separable method. Whenever it is variable separable method, you can solve that differential equation. That is the third method. So totally, the first method is variable separable, second is homogeneous, third is non-homogeneous. In non-homogeneous, we have three cases. One is b1 is equal to minus a2, and the second one is a1 by a2 is equal to b1 by b2, and the third one is a1 by a2 is not equal to b1 by b2. So let us go for the fourth method. Fourth method for solving first order first degree differential equation, that is linear differential equation. An equation of the form dy by dx plus dy is equal to q, where p, q are constants or functions of x, is called a linear differential equation in y. So working rule for this linear differential equation. First, you convert the given differential equation into this form dy by dx plus py is equal to q. So after getting into this form, you write pq functions, p is equal to q is equal to, then you find integrating factor e power p dx. So after getting this one, directly you could write the general solution, y into e power p dx is equal to integral q into e power p dx for dx. Suppose an equation in the form of dx by dy plus px is equal to q, where p, q are constants or functions of y, is called a linear differential equation in x. So for this working rule also the same thing. First you have to express the given equation in this form. So after that you have to write integrating factor e for p dy, then solution is x into e for p dy is equal to integral q into e for p dy whole dy. Let us see the examples on two different methods here. One is dy by dx plus py is equal to q, that means a linear differential equation in y, and other one is linear differential equation in x. So first we have to take the linear differential equation in y. So clearly it is in the form of dy by dx plus py is equal to q form, where p is equal to 2x and q is equal to e power minus x square. Integrating factor e power p dx, this is e power 2x, you will get e power x square. So we have the solution y into e power p dx is equal to q into e power p dx, y into, what is e power p dx? E power x square equal to, what is the value of q? E power minus x square into e power x square dx. So that will be x square minus x square cancel, e power 0 value is 1, and integral 1 dx is x. So this is the solution of given linear differential equation. And next you take one more example here. Dy by dx into x plus y plus 1 is equal to 1. You can write dx by dy is equal to x plus y plus 1. Dx by dy minus x is equal to y plus 1. Clearly it is a linear differential equation in x, where p is equal to minus 1 and q is equal to y plus 1. Then integrating factor is e power p dy, that is e power minus y. The solution is x into e power p dy is equal to integral q into e power p dy. Therefore x into e power p dy value is minus y, and q is y plus 1 into e power minus 1. X into e power minus 1, this is by parts, y plus 1 this is f of x integral g of x is e4 minus 5 and its derivative will be minus 1 minus y plus 1 derivative is 1 and its integral will be minus e4 minus 5. So after simplification you will get this answer. Next, the fifth method is Bernoulli's equation. An equation of the form dy by dx plus py is equal to q into y for n, where p and q are real or functions of x alone. N is a real such that n is not equal to 0 and n is not equal to 1 is called Bernoulli's equation. So if the given equation is in this form, you have to dividing by y power n. So this is the equation we are obtaining after dividing by n. Let us take y power 1 minus n is equal to u, and after substitution every time we are doing the differentiation. So finally you will get this equation. Clearly this equation is in the form of du by dx plus 1 minus n pu into 1 minus n q. That means it is in the form of linear form, that is it's a clearly linear equation in u. So whenever it is linear differential equation, you can solve this differential equation. And the last method, exact differential equations. The necessary and sufficient condition for the differential equation mdx plus mdy is equal to 0 to be exact is dou m by dou y equal to dou n by dou x. So first working rule, you see the working rule. Compare the equation with mdx plus mdy is equal to 0, then find dou m by dou y and dou n by dou x. If they are equal, then it is called an exact differential equation. Whenever it is exact differential equation, then integrate m partially with respect treating y as constant. Integrate only those terms of n which do not contain x with respect to y. So the answer will be integral m dx plus terms of n not involving x. Terms of n which are not involving x, dy is equal to c. You see one example. This is m, this is n. Dou m by dou y, this is dou n by dou x. Both are equal. So then the answer will be integral m dx. So e power y plus 1 cos x n dy. N means terms of n not involving x. So there is no term which is not involving x. That is, therefore this value is 0 dy. Therefore e power y plus 1 integral cos x will be sin x, and this is equal to c. So this is the process to solve exact differential equation. Whenever the equation is not an exact, it is not an exact, by using integrating factor, sometimes multiplying by 1 by mx plus n by 1 by mx minus n by different methods, but to convert into exact differential equation. Whenever it is converted to exact differential equation, we have to use the same process. So this is these are the methods to solve first order and first degree differential equation. So in entire this differential equation, the important things are, so first we have two types of differential equation. One is ordinary and partial. So today we are only dealing ordinary differential equations. In ordinary differential equations, we have three important concepts. The important concepts are order and degree, and the second one is formation of differential equation. Third one is solving the differential equation. In solving the differential equation, we have 6 methods. One is variable separable method, and second one is homogeneous, and third one is non-homogeneous, fourth one is linear, and fifth one is Bernoulli's. The last and final one is exact differential equation. Okay, thank you for giving me a brilliant opportunity.